Our last class we started quadratic function. Suppose we have y, which is ax squared plus bx plus c. So this y is a quadratic function of x. So suppose for when y equals 0, we are interested in getting the value of x. So this becomes a quadratic equation. And last class we already checked one of the method, which is factorization method. But the thing is, not all quadratic equation can be factorized. So we need to look for other methods. And now we are looking into completing the square method. What do we mean by completing the square method? Look at this. Suppose we have this. We have p plus q all squared. Then here we can say this is p squared plus 2pq plus q squared. This is an identity in mathematics called the square of sum. We can show this by expanding this bracket. If you have p plus q all squared, it's equal as multiplying p and q, p plus q twice. By the time you expand, you get this at the end of the day. So what are we trying to do here? So suppose we have p squared plus 2pq or 2qp. Let me write this way. What I need is to rewrite this here. Obviously, this is the same thing as p plus q all squared. Suppose we now have p squared plus 2q into p. This, it is not a perfect square, it is incomplete. What is missing? Q squared. And what's actually q squared? How can we define q squared? Beside p here we have 2q. So how can we define q squared in terms of this coefficient? If we divide this 2q by 2, we are going to get q. But what is actually missing is what? Q squared. So meaning we have to square this. To complete this square, we have to add to it the square of the half coefficient of what? P. So we are going to add half of 2q all squared. If we add this to this, we complete the square. That's what we call completing the square. To understand this gist, let's come back here. We have ax squared plus bx plus c. This is the beginning. Our aim is to get the value of x, but we cannot just make x the subject because it is quadratic. It will be difficult. So from here, we can say ax squared plus bx equals to minus c. We move this to the other side. That is step 1. We can divide through by the coefficient of x squared here, which is a. So from here, we have ax squared plus bx equals to minus c. We divide through by the coefficient of x squared. From here, this cancels this. We have x squared plus b over a x equals to minus c over a. Now, when you compare this with this, they look something similar. X squared, p squared, x, p. What do we have beside x here? B over a. Here we have 2q. So we need to complete this square so that we can express in this form. So what I meant to add here, we'll come here, half of this, we square it. That is what we are going to add. And then to add here, you have to add it here to retain this equation sign. So we have to add to both sides. What are we adding? The square of what? The half coefficient of x. So this is actually what? B over 2a all squared. So we add this to the other side, to the two sides. So originally we are having x squared plus b over a x equals to minus c over a. So right now we want to add to both sides. What are we adding? We are adding this. So that's b over 2a all squared. Anything you add here, you have to add it here also. B over 2a all squared. So this is now a complete square. We've completed the square. That is why it's called completing the square method. So we've expressed this in this form. And anything in this form can be written like this. How? The first number here, p, put it here. The last number here, q, put it here, then square. So the first letter here is x. And inside this line we have b over 2a. We have it. Then you square it. If we expand this, we get this. So we can continue and simplify this part. Then this square is for both b and 2a. So this becomes b squared over 2 squared for then a squared minus c over a. Let's retain this as x plus b over 2a all squared. And let's combine it as a simple fraction. Here, a can divide 4a squared, so the LCM is 4a squared. Then 4a squared divided 4a squared 1. 1 times b, that's b squared. We have minus here. When a divides 4a squared, we have 4a. 4a multiplies c, that's 4a. Our aim is to get the x. So the next, in order to get x, we need to what? Remove this square by looking for the square root of both sides. So in this way, this square root cancels this square. So I'll be having x plus b over 2a equals to, we can split this square root. Square root of what? B squared minus 4ac over square root of 4a squared. And what's square root of 4? Plus or minus 2. So at the end, we're having x plus b over 2a equals to plus or minus. So what do you have here? Square root of 4 is plus or minus 2. Let's put the sign here. Square root of a squared is a. Then this remains as what? B squared minus. No? Something is missing. Oh, okay, we are good. Minus 4ac. Since we want to get x, this plus b over 2a, we have to move to this side. So therefore, x becomes, when we shift this one here, it becomes minus b over 2a. Then plus or minus square root of b squared minus 4ac over 2a. Now we have two fractions there and they have the same denominator. So the LCM will be 2a. So I'll be having x equals to, we have 2a as the denominator. Then we'll be having the addition of the numerator, which is minus b plus or minus square root of b squared minus 4ac. And this is what we call the general formula to solve any quadratic equation. So this general formula is gotten by using complete square method. So for example, suppose we have this question. We have 6x squared plus 7x minus 3 equals to 0. And we want to solve. We can either use completing the square method from the beginning, or we should use this formula below directly. Although in some theoretical question, we can be told to use completing the square method. So now let's solve using the completing the square method, then we use this formula to check if our answer is valid. Alright, we are going to follow this step from here. Step 1, take the constant to the other side. So this is the constant minus 3, bring it here, comes plus 3. So we're having 6x squared plus 7x equals 3. Next, we divide through by the coefficient of x squared, which is a here, which is 6 here. So we divide through by 6 here. So this divided by 6, divided by 6, divided by 6. Then from here, 6 by 6, we have x squared here, plus this 7 over 6x equals to 1 over 2. Now what next? This square is incomplete. So we need to complete the square. Same method here. We add to both sides. What are we adding? This fraction. Now what is this fraction? The square of half coefficient of x. Now the coefficient of x is 7 over 6. So we look for half of the coefficient. Then we square it. And that's actually 7 over 12 all squared. So this is what we are adding to both sides. Originally we are having x squared plus 7 over 6x equals to 1 over 2. But this time we are going to add this fraction. That's plus 7 over 12 all squared plus 7 over 12 all squared. So this is now a complete square. After completing the square, what carries the square here is x. What carries the square is 7 over 12 and it's positive. All squared equals to 1 over 2 plus 49 over 154. So here we are having x plus 7 over 12 all squared equals to, the LCM is 144. So 2 here is 72 times 1, 72. 144 here is 1 times 49, that's 49. So we are having x plus 7 over 12 all squared to be equals to 121 over 144. What next? We want to get the value of x, so we have to remove the square root. Then we have to square root both sides. Then this takes this away. So we're having x plus 7 over 12 here equals to plus or minus 11 over 12. So to get x, we bring this one to the other side. So x becomes, this plus comes to minus 7 over 12 plus or minus 11 over 12. So x becomes, they have the same denominator, minus 12, that's 12, minus 7 plus or minus 11. So we have two signs. So the first value of x, which is alpha, is when you use the plus, minus 7 plus 11 over 12. Or if you use the minus 7 minus 11 over 12. From here, x becomes, so minus 7 plus 11 will give us 4. So that's 4 over 12, which is 1 over 3. Or here, minus 7 minus 11 is minus 18. So if you have minus 18, it means 6 will be common. 6 in 18 will be 3. 6 in 12 will be 2. So the answer will be minus 3 over 2. This alpha is beta. So these are the roots of this quadratic equation using completing the square method. So I'll take another example. Before that, let's use the general method, general formula to show the same answer. So I'll play this now so we can use the general formula. Now let's use general formula to solve the same question. So step 1 is to write the general quadratic equation below. A squared plus bx plus c equals 0. From here, by comparing the coefficients, a is going to be 6, b is going to be 7, and c is going to be minus 3. So using the same formula, x, which is what we are looking for, is minus b plus or minus square root of b squared minus 4ac divided by 2a. So where x becomes minus, what is b? B is 7 plus or minus square root of 7 squared minus 4. A is 6. C is negative 3 over 2a and a is 6. X becomes minus 7 plus or minus square root of 7 squared 49 minus minus plus. So if you multiply 4, 6 and 3, you get 72. Divided by 2 times 6, 12. So x equals to minus 7 plus or minus square root of 121 over 12. So x becomes minus 7 plus or minus 11 over 12. So x becomes minus 7 plus 11 over 12, or minus 11 minus 7 minus 11 over 12. From here, x equals to 1 over 3 or minus 3 over 2. Same answer, and it's shorter and less stressful. So one of the best method is to use the general formula. We use completing square method when you have no choice than to use it, if you are told to use it. And for factorization method, it can only be used for quadratic equation can be factorizable. How are you going to know that? We are coming there. So let's solve another question using general formula. Suppose we have 2x squared minus 3x minus 2 equals 0. So we are going to use general formula to solve this. Then after, I want to apply completing the square method. So by comparing, if you have to bring this one beside and under this, it means this question of x squared is a. So from here, it means a is 2, b is minus 3, and c is minus 2. This a, b, c. Using the formula here, our x equals to, let's put the value straight. We have minus, minus. Then b is minus 3. Plus or minus square root of b squared, that's minus 3 squared, plus minus 4, a is 2, c is minus 2. Everything divided by what? 2a. From here, x becomes minus minus plus, that's plus 3, plus minus square root of 3 squared is 9, minus minus plus 4 times 2, 8, 8 times 2, 16, over 2, oh I didn't put a here, a is 2, 2 times 2 is 4. From here, x becomes 3 plus or minus 25 over 4. Then using the plus, x equals to 3 plus root 25 is 5 over 4, or x equals to 3 using the minus, root 25 is 5 over 4. 3 plus 5, 8, 8 over 4, 2. So it means here x equals to, or 3 minus 5 minus 2 over 4, that's minus 1 over 2. x equals to minus 1 over 2. As simple as that. We've solved this one using what? General formula. This also using general formula. And if you observe, this same equation, these two equations are what we used yesterday as example. Sorry, in our last class. So now, for this one, let's use completing the square method from scratch like we have it here, so that you master it. Now let's start. Alright, using completing the square method, let's solve this. Solution. What's step 1? Step 1 is to take the constant to the other side, so we're having 2x squared minus 3x equals to 2. Step 2, divide by the equation of x squared, which is 2 in this case. So divide by 2. Divide by 2, these two go away, I'll be having x squared minus 3 over 2x equals to 2 over 2, 1. Take this to the other side, divide by what? The equation of x squared here. So we have this. Then from here, when you get here, we now complete the square by adding to both sides. What are you adding to both sides? The square of half coefficient of x. The equation of x here is minus 3 over 2, not 3 over 2. You have to include the negative sign. Minus 3 over 2 all squared. And that's minus 3 over 4 all squared. That is what we are going to add to both sides. So here we are having x squared minus 3 over 2x equals to 1 ordinarily. What are we adding? We are adding minus 3 over 4 all squared minus 3 over 4 all squared. From here we can proceed by factorizing. So we've already completed the square. So we pick the first letter here, x. And here what do we have here? Minus 3 over 4. Ensure this minus is always with it. If not, you will get it wrong. 1 plus minus 3 squared 9, 4 squared 16. So here we have x minus 3 over 4 all squared. 6 times 1, 16 plus 9, that's 25 over 16. To remove the square, we have to square root both sides. Square root this, square root this. So from here, this cancels this. So we are having x minus 3 over 4 equals to square root of 25 is plus or minus 5. Square root of 16 plus or minus 4. The remaining to this side, x equals to this minus turns to plus 3 over 4. Then plus or minus 5 over 4. So x equals to 3 plus or minus 5 over 4. Using the positive, x is 3 plus 5 over 4. Or using the minus, 3 minus 5 over 4. So that's what we have here. So from here, x equals to 2 or minus 1 over 2. As simple as that. So with these examples, it means you've mastered 3 methods. Factorization method, which we've done in our last class. Completing the square method and the use of general formula. So the last thing will be graphical solution. But before that, let's talk about the nature of the root of quadratic equation. Now, we've already established that for a quadratic equation of the form ax squared plus bx plus c equals 0, the value of x can be expressed as minus b plus or minus square root of b squared minus 4ac divided by 2a. So this is the general formula. And we are going to have 2 roots. The first root is when you use the plus. The second root is when you use the minus. So what we have here, b squared minus 4ac, it has a name. We call it the discriminant of the quadratic root, which is letter d to represent it. And the value of d here, will tell us the nature of the quadratic root. So what are the possible value of d? Before that, let's show the roots. The first value of x, the first root, we call it alpha, and alpha is minus b. Using the plus, everything here is what? Root d over 2a. Then the second root, beta, is minus b minus root d over 2a. So what will the nature of these two roots? For some conditions, they are equal. For some conditions, they are both real numbers. Sometimes they are both complex. Sometimes they are natural numbers. Now let's look into them one by one. Case 1, if d is less than 0. If d is less than 0, it means d is negative. And if d is less than 0 from here, it means b squared minus 4ac is also less than 0, which implies that b squared is less than 4ac. It's either we say b is less than 0, or b squared minus 4ac is less than 0, or b squared is less than 4ac. All these conditions, they are the same. If we have this condition, it means the roots alpha and beta are complex. Why? Because this square root of negative number is complex. If d is less than 0, it means d is negative, perhaps minus 2. Then square root of minus 2 is complex. So it will have no real root. It will have no real root. And we know for a Cartesian plane, it's representing real numbers. So let's put this y, and this is what? X. So a quadratic graph is either u or n. Let's use u for this case. So for this case, it's not going to touch, because this is where y equals 0. This 0 represents the value of y. So we have something like this. Meaning it's not going to cross x axis at all. It has no real rule. It is what? Complex. Case 2, if d is 0, we know d is b squared minus 4ac. So if d is 0, it means b squared minus 4ac is also 0, which implies that b squared equals 4ac. Now, if d is 0, square root of 0 is 0, square root of 0 is 0. Minus b plus 0 is minus b. Minus b minus 0 is still minus b. It means alpha and beta, they will have equal value. It means the roots are going to be equal. So it implies that alpha, beta are equal. So meaning the roots are equal. Condition equal roots. And if the roots are equal, you know, for every quadratic equation is a product of two linear equations. It means those two linear equations, they are identical. When those two linear equations are identical, when we multiply, it turns to a perfect square. So it means the quadratic expression itself will be a perfect square, and the expression will be a perfect square. So this is a condition for quadratic root, or for a quadratic expression to have equal root, or for a quadratic expression to be a perfect square. B squared must be equal to 4ac. Now, if you have to sketch this one on a graph, it means alpha and beta will coincide. Suppose they are both positive, we are going to have something like this. So alpha, beta, they are both equal, where y is 0. Let's take one example on this. Consider this equation, this quadratic equation. Now look at this. This is actually a perfect square. You can show it. If we use general formula to solve this, we are going to get two values of x, and we are going to get 2 over 3 twice. And if we have to factorize this, we are going to be having 3x minus 2 all squared equals 0. If you factorize, this is what we are going to get. Before having this, we are having 3x minus 2, 3 minus 2. Then if you multiply together, you have this to be a perfect square. So a question can come in this form. They can ask us that look for the value of k, or for what value of k is this expression a perfect square. Let's give it an example. Now, for what value of k will expression 4x squared minus 3kx plus 9 be a perfect square? Now, for any quadratic expression to be a perfect square, or if it's equation they will put equal to 0, or for any equation to have equal roots, the condition is that b squared must be equal to 4ac. Now, if you write this below it, you have to write as squared plus bx plus c. And from here, obviously, a is 4, b is minus 3k, and c is 9. And what's the condition? B squared must be equal to 4ac. Then from here, what's b? Minus 3k. Minus 3k all squared must be equal to 4a. What is a 4? What is c? 9. So for me, I'll be having 9k squared equals to 16 times 9. So this 9 can cancel this 9. So it means that k squared equals to 16. To get k, we look for the square root of both sides. So therefore, it means k is plus or minus 4. K equals to plus or minus 4. So that's value of k. When k is 4, this equation becomes a perfect square. Let's try it. Let's put 4 here. So I'll be having 4s squared minus, you have to use 4. 3k means 3 times k, 3 times 4, 12. Plus 9. If we factorize this, which we've done in our previous lessons, if we use factorization method to factorize this, we are going to get this one to be equals to 2x minus 3, 2x minus 3. This is what you get. And this can also be expressed as what? 2x minus 3 all squared. If it's the equation equals to 0, it means 2x minus 3 is 0, 2x minus 3 is 0, we get x to what? 3 over 2 twice. So that is for this case, if the roots are equal, if this is 0, we've done negative d, when d is less than 0, when this is 0, let's now go to when d is greater than 0. But before that, note, b and a, they are real numbers, they are not complex. So not only that if d is 0, they have equal roots, they have equal roots, and the roots will be real. So the roots are going to be real, and they're going to be what? Equal. Now, let's go to case 3 when d is greater than 0. If d is greater than 0, it means b squared minus 4ac will also be greater than 0, which implies that b squared is greater than 4ac. So it means d is positive. If d is positive, the roots of positive numbers are called real numbers. It means the roots alpha and beta are real. They are real numbers. Note, this also real numbers equal. Real numbers but not necessarily equal. Or we can put or equals to 0. You put or equals to 0 here, it means d can also be 0. Meaning for some values of alpha and beta, or for some equation falling under this condition, they can also have what? Equal roots. This means equal roots and they are real. This means real roots but not necessarily equal. So let's move this. So this means what? Real but not equal. This is what? Equal and real. Real not equal. If I put equals to 0 there, it means it's real and can also be equal. Let's put it this way. Then under this case 3, we now have a special case. If d is greater than 0, it means d is a natural number. Because greater than 0 means what? Positive. So d is a natural number. So part of natural numbers we have, let's write some of them. We have 1, 2, 3, 4, 5, 6, 7, 8, and the likes. Okay, let me continue. 9, 10. They are all, so meaning d can be 1, can be 2, can be 3, cannot be negative. So part of some of these numbers are perfect square. Example, 1 is the perfect square, 4 is the perfect square, 9 is the perfect square. So if the value of d is a perfect square, meaning if d, which is greater than 0, is a perfect square, meaning square of a natural number. For example, this can be written as 1 squared, 4 as 2 squared, 9 as 3 squared. If d is expressed in terms of what? N squared, so it implies that the equation or the expression is factorizable. You know, I said not all quadratic expression can be factorized, but if d is a perfect square, it can be factorized. Okay, before we take an example on this, if you have to sketch its graph, how is it going to be? So it's going to cross the x-axis into region. It's either like this. If it's like this, it means one of them is negative, the other is positive. You can also have it this way. You can have it this way, meaning the two roots are negative, or this way. The two roots are positive. So this is alpha, beta, alpha, beta, alpha, beta. We are going to get minimum curve if the coefficient of A is what? Positive. If A is positive. But if A is negative, it will flip. So we have the opposite. So for this one, A is less than 0. So one is positive, negative, positive, both negative, both positive. So any of these two, are the graph for when D is greater than 0, we get real numbers. You get real roots rather. A and B are real roots, or you can call them real numbers. For this one also, the assumption is A is greater than 0. If A is greater than 0 to flip, we're having something like this. But for this, they are both positive. It can also be other side here. Likewise, this is A greater than 0. If A is greater than 0, we have something like this. It can be here, here or here. So I think here we've already discussed about what nature of quadratic roots. So if you are given any quadratic equation, I don't use general formula or completing the square method. If you want to factorize and it's giving you problem, getting the factors is very difficult, meaning it's likely that it's not factorizable. So what are you going to do? You look for the value of d. If d is the perfect square, then it is factorizable. And what was d? D squared minus 4ac. I think with this we are done with nature of quadratic roots. So what I'm going to focus next should be graphical solution. How do we solve quadratic equation graphically? We are done with factorization method, we are done with completing the square method, and we are done with using the general formula. And we've discussed about nature of the roots of quadratic equations. Then the next thing is graphical solution, which will be for our next class. But before that, let me reconstruct this condition. Let's put all equals to there. Why? Because these two equal roots here, they are also what? Real numbers. So let's make it inclusive. So question that will come on this form, they can give you a particular quadratic equation. Suppose we have 4x squared minus 5x plus 9 equals 0. They now ask you, what is the nature of the root of this particular equation? You don't need to know the value of x. You don't need to get the value of the roots before you can know the condition, the nature. So what I meant to do, get the value of d. What was d? B squared minus 4ac. So in this case, d equals to b is minus 5. Minus 5 squared, 25. Minus 4ac. 4 times 4, 16. Since 99 will give us more than 25. So our d will be less than 0. So meaning these roots are going to be complex for this particular one. Meaning if you use it, if it's complex, it cannot be factorizable. So this is not going to be factorizable. So you have to use general formula, and at the end you get this. You get square root of a negative number which is complex. So to know the nature of the roots, you don't need to solve. Just get the value of d. And from the equation, you can always get the sum of the root and the product of the root without actually solving two. We've done that yesterday. So see you next class for graphical solution.